Okay, good morning, guys. So today is the day I'm sure we've all been waiting for quite some time, where we finally learn how to graph an equation, a linear equation, using the slope and the y-intercept as opposed to using a table, right? So using a table was kind of tedious. We had to make the table, get our calculators out to do the substitution, and then write the ordered pairs and plot the points. So there's a much easier way of doing it, right? Now we spend some time on the table so we make the connection between the two. But we're going to learn a much faster method today. So let's review what I do now, and that's going to link to what we do today. So what's my slope and y-intercept for the first one? So my slope is the coefficient of x when the equation is solved for y, so that's 3/4, and my constant is my y-intercept. For the second one, my slope again is my coefficient of x, my constant, which is my y-intercept, in this case is 0, and for the last one we know we need to solve the equation for y. So that's going to give us y equals 2x minus 3. So m is equal to 2, whereas b is equal to negative 3. All right, so really important stuff here, right? So we're going to put all of this in our notes, right? Slope-intercept form. Now, you guys have heard me talk about slope-intercept form, but we haven't actually looked at it. I mean, we haven't looked at it explicitly like this. So when an equation is in slope-intercept form, which means it's solved for y, the coefficient of x is m, right? That's our slope. And the constant is our y-intercept, which that we've talked about, right? So in this example, y equals negative 2x plus 3. My slope is negative 2 and my y-intercept is 3. So we can at least get a mental image of what this graph is going to look like, right? I know that this graph is going to pass through 3 on my y-axis. And I know that it has a slope of 2, meaning I go down 2 and then 1 across, or 1 to the right. So I can graph the line really quick, and that's exactly what we're going to do today. All right, so let's talk about it. Slope, right? Slope, we said, is rise over run, which means the slope has to be a fraction, okay? Negative 2 right now is not a fraction. How do we express a fraction from an integer? We make a denominator of 1. So a slope of negative 2 would be negative 2 divided by 1. All right, now let's explain what that means. So that means my rise over run is equal to negative 2 over 1. Okay, now what does it mean to rise negative 2? It means I'm going to go down 2. And what does it mean to run positive 1? It means I go 1 to the right. But there's another way I can express negative 2, right? Negative 2 over 1 is the same as 2 over negative 1, right? Because negative 2 divided by 1 and 2 divided by negative 1 are both going to give me negative 2. So what does that mean? Well, how would I rise positive 2? I can go up. And how would I run negative 1? I'd go to the left. So there's two ways to interpret the slope. Do we need both of them? Not necessarily, but again, it's a connection that we need to make. So what's the first thing I'm going to do when I'm graphing any line? The first thing I'm going to do is I'm going to plot my y-intercept. So the y-intercept is 3. So I know that there is a point here. I know that the line goes through 3 on the y-axis. So if you're making like a little list of graphing a line using slope-intercept form, number 1 in your list is plot the y-intercept. What is step 2? Apply the slope. So this version of the slope, negative 2 over 1, tells me to go down 2 and 1 to the right. So why don't I do that? Down 2, 1 to the right, down 2, 1 to the right, down 2, 1 to the right, down 2, 1 to the right. But there's something else I can do. I can use this version of the slope that tells me I can also go up 2 and 1 to the left. That's it. All right, so let's get our rulers out. Let's connect those points. Let's use arrows and let's label. And that's it. Let's take a look at another one. What's my slope? Half. Well, I'm actually happy when my slope's a fraction because I don't have to convert it into a fraction. What's my y-intercept? It's right there. It's negative 4. So what's the first thing I can do? Well, I know that my y-intercept is there. So the first thing I do is I plot the y-intercept. Now I need to talk about my slope. So my rise over run, right, is 1/2. So what does it mean to rise positive 1? It means to go up 1. And what does it mean to run positive 2? It means go to the right. Now, how else can I express 1/2? And this is hard, and someone always will say 2/4, and I'll say, sure, that's true. And then I say, well, what if I want to change the signs? And then someone will say, well, what about -1 divided by -2? Because when we divide a negative by a negative, the quotient is positive. Now, what would this require us to do? Well, this would require us to rise -1, which would go down, and run -2, which means run to the left. So I'm probably going to want to apply both of these. Let me take a look at my first version. Go up 1 and 2 to the right. Okay, I can do that. That's not so bad. All right, I ran out of space. Let me check out my second version. This one tells me to go down 1 and 2 to the left. Well, that's consistent. I'm on the same line. Now, if you end up with something, guys, right, you're graphing, well, that we would not want, and then you end up with something like this, obviously you didn't apply one part of the slope correctly, right? We're only dealing with straight lines, no lightning bolts, nothing curved. So I'm going to connect my points. I'm going to label after I place my arrows, so y equals 1/2 x minus 4. All right, this one gets a little tricky, right? The slope is -3/4. And my y-intercept is 0. That's easy. I'm going to put a point at the origin. Now, let's talk rise over run here. And this is the connection that if you understand this, you're going to be pretty much set for all of the graphing. And if you're kind of not really paying attention, you're going to end up struggling, right? How do I express negative fraction in rise over run? Well, I can express it in two different ways. I can say -3/4 is -3 divided by 4, or I can say it's going to be 3 divided by -4. All right, so again, guys, if the fraction is negative, it means either the numerator or denominator is negative, but not both. What does it mean to rise -3? I'm going down. What does it mean to run +4? It means I'm going to the right. All right, that's version 1. Let's check out version 2. Rise 3, that means I'm going up. Run -4 means I'm running to the left, and these will be consistent with each other. So I'm going to apply this first version now. I'm going to go down 3 and 4 to the right. Can't do that anymore. Now I have to use my other version. I'm going to go up 3 and 4 to the left. And they end up, of course, on the same line. This one should actually be pretty easy, right? What's my slope? Well, my slope of 1x is 1. So let's just be careful and not do something silly like, say, the slope is 0, right? 0x would be y equals 3. That's a horizontal line. We talked about that already. So I can plot my y-intercept, and my slope is 1. Okay, so let's talk rise over run. This should actually be really easy. My rise over run is 1 over 1. Or I can also express it as -1 over -1. So what does it mean to rise 1 and run 1? Well, that's easy. I go up 1 and I go 1 to the right. What does it mean to rise -1? I go down 1 and run -1 means run left. All right, that shouldn't be so bad, right? This is like what we talked about the first day of slope, right? A line with a slope of 1 goes up 1 and right 1. So I get a whole bunch of points I can plot here. You don't need to plot all of them, of course. All right, and there's my line. All right, so we can skip this because we looked at a very similar one at the beginning. We could skip this as well. And there's your homework. All right, so you're going to take those 3 lines. You're going to graph them on the same grid is okay. Separate grids would honestly be a little bit better to look at, but same grid is fine as long as you make a nice big grid. I'd make it a little bit bigger than this one. Maybe 10 by 10 would be good if you're doing all 3. And questions, comments, concerns, post your work, and then comment on Google Classroom.